If you scroll through enough travel feeds, you'll eventually hit the same loop of alpine perfection: crisp air, quiet valleys, and an overwhelming sense of deep, untouched peace. But that absolute stillness is a trick of human perspective. These mountains formed through a massive, violent upward surge that took millions of years to complete. The landscape we see today is actually the shattered and elevated debris of an ancient, slow-motion planetary collision. Identifying the specific, massive natural forces that forced this specific patch of Europe toward the sky reveals a much more chaotic history. To understand the reality of this landscape, we have to look past the scenery and identify the specific markers of high-pressure geological movement. Go back roughly 65 million years, and the space currently occupied by the Alps wasn't sky at all. You would be standing on the floor of the ancient Tethys Ocean. The African tectonic plate began an agonizingly slow drift north, heading straight for the Eurasian plate. The space between them rapidly compressed. The ocean floor had nowhere to go but up, buckling under trillions of tons of pressure, folding over itself mile after vertical mile. Those towering spires of rock slicing through the clouds today are entirely composed of prehistoric seabed, limestone and granite forced from the deep crust straight into the stratosphere. Look closely at the Matterhorn. Those sharp angles and distinct layers are the physical remnants of that tectonic fold, locked in place after being thrust miles into the air. Now frame that massive wall of upthrust rock against the small biological life resting in the valley below. The sheer vertical drop makes the raw scale of the tectonic wreckage obvious. Every inch of staggering height in the Swiss Alps is a direct, measurable result of two continents locked in an ongoing collision. But pushing rock into the sky only builds rough, unrefined walls. The sweeping, cinematic valleys require a completely different tool: the massive climate shift of the Pleistocene ice ages. As temperatures plummeted, snow packed tightly into ice. Glaciers thousands of feet thick began to fill the harsh, narrow tectonic cracks. These massive, solid rivers of ice didn't just sit there, they flowed. Acting as planetary-scale bulldozers, they ground against the narrow passes, tearing away millions of tons of stone to widen them. We know exactly how this happened because the remnants of those giant tools are still sitting up there. Massive ice flows continue their slow, heavy grind downward through the high valleys today. Those dramatic, sheer cliffs and wide valleys that look so perfect from above are actually the hollowed-out channels left behind by vanished rivers of ice. As the climate eventually warmed, those immense glaciers retreated uphill, leaving deeply gouged-out trenches in the valley floors behind them. Those empty basins acted as colossal catchments. Melting ice poured down the mountains, filling the geological voids to form Switzerland's deep, iconic lakes. The water that fills these basins possesses a famous, hyper-vibrant blue coloration. That aesthetic comes from a specific byproduct of glacial erosion called rock flour. This diagram breaks down the mechanics. The glaciers pulverize mountain stone into a fine, microscopic dust that remains suspended in the lake. When sunlight hits these floating particles, they absorb certain wavelengths and scatter the blue and green light back out to the surface. Human civilization built itself entirely around this violent hydrology. The steep, carved-out river systems and deep lake basins became the immediate foundation for tiered agriculture and vital trade routes. The vibrant color of the Swiss lakes results from mountain stones pulverized by ice millions of years ago, a lasting signature of the region's glacial history. Pull back from the geological past, and you'll see exactly what this massive structure does today. Switzerland operates as a vital, active natural engine for the rest of the continent. The extreme high-altitude topography acts as a physical net for weather systems moving across Europe. It catches heavy precipitation and locks millions of tons of it high up in the peaks as glacial ice. That stored water continuously melts and drains downward, combining to form the roaring headwaters of major European arteries, specifically the Rhine and the Rhone. This gravity-fed flow sustains large-scale agriculture, stabilizes complex river ecosystems, and provides water for millions, thousands of miles beyond the Swiss border. When you look at the towering beauty of this landscape, You are actually watching a colossal, life-giving water tower, performing exactly the function it was built for. The Alps stand as the physical aftermath of a continental collision, a landscape refined by ice that now functions as the vital reservoir sustaining much of the European continent. Thank you for watching.